Hello. Welcome back to Coding Bootcamp's Introduction to the Python Programming Language. Last time we talked about language fundamentals, and as a recap, when we discussed Python's lexical analyzer, we skipped over something I'd like to expand on a little bit, and that is the idea of physical lines and logical lines. Okay, so here we also declare the coding for this file to be UTF-8. We talked about that, but there's an example of it. If we had a different character set, see down here we could change our character set to Latin 1. But most files use UTF-8. So here we're setting 3 variables, and each of these variables is a single logical line. Each of these statements exist on a single logical line, but each of them take up 2 physical lines. So the first is an explicit line joining method with the backslash. Has to be the last line. See, this is not, if it has an extra space here or anything after here, even a comment doesn't count. It's not valid. But if the backslash is the actual last character, then it will join the next line. And this is an implicit line joining with a type of, so we have here parentheses, but you can split up dicts or lists in multiple lines same way. And this is a multi-line string. So let's print those out, see what we get. Yeah, there's X, there's Y, and there's Z, multi-line. So we could print, we could make this instead a tuple. We'd say 1, 2, 3. Yeah, that looks valid. Our ID does not complain. Let's print them out. Right. There's X, there's Y, and there's Z. Okay. So that was language fundamentals, and this time we're going to get into flow control constructs. Alright, so let's get into it. The objectives of this video are to talk about if, elif, and else statements, the if suite, also about creating loops with while and for, understanding iterators, returning values with the return statement, loop modification with break and continue, returning, and talk about a bit about generators and iterators. Okay, first, one of the primary functions, one of the primary uses or implementations of a programming language is a branching mechanism. So to go left or right, true or false, and Python is no exception. So the traditional if-else in Python, in JavaScript, we can say else if or else if. But in Python we have elif. So the syntax in Python is an if statement. It begins with the if keyword, and then we have an expression, and then we have a colon. So that makes up our if statement. So this if statement begins a block, which are called suites in Python, and consist of code that is indented under the level of whatever's controlling it. So here we have an indentation. So this is a block, and that ends because we're unindented at elif. Same thing with a colon, begins a new block. And finally we have the else branch, then colon, and a third block. So how this works is, remember we have the if statement, the expression, and the colon. So the main thing we're looking for, so it's on the left it's the if, and on the right it's the colon. So we're basically talking about expressions. So we say, if this is true, then we execute this code. Else, if this is true, so if this is false, then we'll continue. If this is true, then we print this statement and we're done. And we're done with this whole structure. Right? But if this is false, then we'll check the second expression and see if this is true. If that's true, then only this is executed. And if both of these are false, then we'll skip down to the else, and then it'll catch all, and finally this will print. So only one of these will print it at any time. Only one can print, and then afterwards, the next line after this whole structure is printed. So what do you think is going to be the result of this? Which line do you think is going to be executed? All right, let's have a look. Let's enter our Python interpreter. Let's paste in our code and see what happens. A5 is greater than B, which is 1, right? So in the beginning, we set this construct might be a little we haven't talked about this before, but here is our assignment operator. So on the left we have the assignment variables are created and assigned, and on the right we have the values. So this is actually a tuple and a tuple, and they're deconstructed so that 5 goes into A and 1 goes into B. So this is the same thing as saying A equals 5 and B equals 1. So if we run this, if A is less than B, right? So if 5 is less than 1, no, that's not going to happen. So it's going to go here. If A is greater than B, 5 is greater than 1. So this prints out. This is introduced in Python 3.6 F strings. Love the F strings. So this looks in your locals dict for different variables. And you can see A is 5 and B is 1. So if A is greater than B, then prints this, and that's what it does. It prints A, then the variable is greater than B, and then the variable B. That's all inside of this quote. So it's a shortened syntax for printing values inside of strings. So conditional expression syntax is a bit different than C-based languages because the Python designers wanted to make the syntax easily readable. Right? So foo if A is less than B, else bar. Does that make sense? Let's try it. Bar. Foo if A is greater than B, else bar. And prints foo. So we print foo. This is saying print foo if A is greater than B, else bar. Another way to say this would be if A is greater than B, print foo. Else print bar. But this is a lot shorter. So let's create some loops with while and for. While and for are two fundamental types of loops. Let's first look at the while loop. So we're going to start a simple Fibonacci series. And a Fibonacci series is the sum of the two elements defines the next set. Alright, so again we see this deconstruction here. A equals 0 and B equals 1. So while B is less than 50, we start our loop. Right? So before we had the if statement and a colon, and now we have a while statement and a colon. And again, we have an expression in the middle. So expressions are evaluated. So while, the interpreter will evaluate this expression. So B starts off as what? B starts off as 1. So while, so the first time it goes through, it will evaluate while 1 is less than 50, and it is. So it will enter the loop, right? So the first time it comes through, it will enter the loop, and it will print the 1, and then it will set A to B and increase B by A. Right? So after this statement, A will now equal 1. A starts off as 0, but now it's setting A to B. So now B starts off as 1, and now after this, A will equal 1, and B will equal A plus B. Let's try it. So A, at the end, A is 34 and B is 55. So we go through the loop. First time through, if 1 is less than 50, it will print the 1. And then it will set B to be, well, 1 again, because 1 plus 0. Second time through, B is still 1. And it has 1 plus 1, because A is also 1. Third time through, it prints off the B is 2. And now adds the 1 from, which is A. So now it's 3. And it continues like this until A is 55. And it says while 55 is less than 50, while 55 is less than 50. Nope, it does not enter the loop. And now the final time it skips it. So as long as the condition is true, the while loop will continue to execute. Indentation after the colon indicates that the code is part of the loop. Now, for loops. For loops work with an iterator. And in actuality, it's an iterator expression. An iterator is an object that each time you call it, it gives the next value. Below, code opens a file called lines.txt and prints the lines in the file. fh is the file handle, and the method readLines is an iterator function. What it does is it takes one object at a time from a sequence of objects and returns those one at a time. So each time the file handle.readLines function is called, it will put the next value in the line variable, which is the next line of text. Let's see it in action here. All right, as you can see here, we are executing this open function. And we can let's look at it. Let's say open. So open wants a file handle, which usually it's a string. You give it the name of the file. And you can also give it the mode for reading or writing. Reading, it will assume read mode if you don't tell it. You can tell it the encoding of the file. It will make assumptions. But basically, we want to tell it the name of the file. Alright, so here we go. We're going to try to open it. Oh, FH is not defined. Alright, so now when let's try to define it. Oh, if we try to define our handle, it says no such file or directory, lines.txt. Alright, that's fine. So, files do we, let's see, let's see, we have, let's create a new file here. Lines.txt, and we will, let's edit it. Let's say the first line is let's be creative, line number 1, and then line number 2, and then, you guessed it, line number 3. Alright. Cat is like print, the contents of. So there's our 3-line file. Alright, so now lines.txt should exist. Now if we go to Python and we type in, let's create a file handle, and we'll call open for lines.txt. Alright. So FH is now a text.io wrapper. So we can say for line in fh.readLines, which is our iterator. There's our colon, so we have our expression in the middle, and our expression actually is an iterator expression, so this will evaluate to an iterator. This is an iterator. So let's print the line. Alright, so if we wanted to be fancier, we could say print the line, and now the end is, instead of a new line character, because this is the default is this. So we need to, so why didn't that print anything this time? Well, because our iterator was expired and we went to the end of it. So now if we try to call next on it again, it's already at the end. So we need to open it back up again. We create a new object. We could just reset it though also. Right. So let's run it again. And this time, instead of printing a new line at the end, let's just print our lines. Because the file already has new lines at the end, so we don't want to be too redundant. Alright, so all Python functions return the value none unless there is an explicit return statement. So a return statement, once executed, immediately terminates the function, even if it's not the last line of the function. So if we had this function here, square, you pass it one variable, one positional argument, then we can call it with, this will call it with the value of 10, and it should print the result is this. All right, so as we learned before, we can use f strings. Maybe we can clean this up a little bit. So the result of, let's convert 2 square to a string. Okay, let's first print it like this. Should we? Just to see what we got. All right. I don't want to get too confusing here, but all right. So let's put this in our interpreter and see what we get. Shall we? Okay. So now, do we have our square function? Okay. So we can call square of 10. It's 100. So 10 squared is 100. And negative 1 is 1. Negative 0.234. That squared is 0.05. Okay, so let's set 2 square is 10, right? So we basically did this already. So let's say the result equals square of 2 square. Now what's the result? The result is 100. So let's take our print statement again that we typed in. What did we type in here? We typed in print, the result of is string of a result. Valid syntax. Well, we are using Python 3, so we should be using, remember, Python 2 was a statement, but Python 3, print is a function. So you have to use parentheses with functions. All right, the result of 10 squared is 100. Now how can we clean this up a little bit? We can say the result of We make it an F string. We pass in our variables. Everything is within the quotes. Squared is, and it will make all these strings, even though we're dealing with integers here. Alright, so don't forget to terminate your F string. So it's just a little cleaner. F strings are a little easier to understand. Make Python even easier to read. Alright. So moving on. Sometimes you need a way to shortcut the loop or break out. You can do that with the continue. The continue right here. So if, alright, so we say S is a string, and a string is a sequence. It is also iterable. So you can iterate through S. Say for C in S. So C in S. This is the for loop syntax for iterating. This needs to be an iterator. This is another keyword, and this is the variable you're defining. So every time you iterate through one character through the sequence S, which is one character at a time. So the first time through, C will be T. The second time through the loop, C will be H. Third time through, I, S, space, and so on. So the first time through, C is what? T. So it says if C equals S, no, C is not S, C is T. Then it will continue, but that's false, so it will go to the next line. So we will print C. Second time through, H is equal to S, no, so it will print H. Third time through, print I. Fourth time through, if C equals S, that's true. Fourth time through, C, this is true, so it will go to the continue, which means it will go right back to the for. It'll skip everything afterwards. Let's see it in action. Right? So it's skipping all of the S's. Isn't it? All right. S is a string. For C and S, we're going to check if C equals S. If it is, continue. And if not, we are going to print it out. There we go. He's skipping all the S's. Break also terminates a loop. Where continue will go back to the next iteration, break will break out of the loop completely. Alright, so what do you think this is going to look like? What's your guess? What's this going to do? THI, and instead of skipping the S, it just terminated the whole loop and broke out of it. Okay. Generators. Generators will help you expand your mind. They are one of the more difficult topics in Python, and even Guido has a little trouble with them, he says. And when you get into async programming with async generators, you're really going to be able to blow your mind, because generators are very powerful. A lot of programming languages have them. So they're like functions, except they have a yield statement. So the yield is like a return. It returns a value, but the next time the function's called, it continues after the yield. So in the following code, we're going to look at generator iterators. All right, so returning generator iterators with the yield statement. All right, let's define a function, and we will call it, well, we're defining two functions. All right, so one function is called isPrime. The next function is called primes. And you see primes contains this yield. So there's no yield over here. This is a regular function. And we haven't talked about functions yet, but this is how you define a function, def, D-E-F. The same like we had our for, we had an expression, and we had our colon. When you define a function, you give it the function signature, and then you give it the colon. All right, so this is a function definition, and we begin a new block. That's the function body, the block. And now over here we have another function we're creating. But this function actually contains, see how we're unindented here, so this for down here is not part of the function. The function body only exists while we're indented. But you can see this function, here is the name of the function, primes. There's our definition of it. So this function contains a yield. So the lexical analyzer, when it's running through all your code before it gets interpreted, it will define this as a generator function, a special type of function. So when we call it down here, let's try it. We're going to see how it works. All right. So we've defined our two functions, isPrime and primes. Now, what do you think this is going to look like when we call it? We're going to create a loop, and this is our expression, which is an iterator, because we're calling an iterator function, which happens to be a generator. And then we begin our block, and we say if n is less than 100, we're going to break out. So we're going to basically list the first 100 prime numbers. All right? Because if you haven't noticed, isPrime is a function which given, here is all of the parameters. It only has one positional parameter, n. So given the parameter n, we're going to check if it's equal to 1, then we're going to return false, because 1 is not prime. Okay. And then this function will exit right there if that's true. If it's not true, if n is not 1, well then it will continue with the rest of the function body. So it will check in a for loop, it will loop from 2 until n. So, and we'll check if it can be divided. We'll check if it can be divided by x if the remainder is 0. So this is if the modulus of this number is 0. Checking if it's divisible by anything other than it's, if it's not 1 and it not including itself. If it's divisible by anything, if it has no remainder when it's divided, then it will say nope, it's also not prime. So if it's 1 or if it's divisible evenly, then it will return false. It's not a prime. Otherwise, it is a prime number. All right, so that's this function. So in our main body here, we're calling primes, which is our generator function, remember, because it contains a yield. We're calling isPrime. So we're starting off at 1, and we're saying, while true, we're beginning this big loop here. This was called an infinite loop, while true. It never exits. So infinite loops are normally a bad thing, but in generators, we only execute this one time, the first time, because the execution actually stops the yield. So when the function's first time it's called, it will come through. Of course, this will be true. It will call isPrime on 1, and isPrime 1 is 1 prime. Does isPrime 1 return true, or what evaluates to a Boolean true? Does anybody know if 1 is prime? What do you think is going to happen? Well, 1 is not prime. So it will not get to this. It will go to n plus 1 and go back up to the loop, and we'll say if is prime 2, and 2 is prime. Nothing else, this is not true. So it will yield 2. 2 is prime. But then it will stop. After it yields the 2, it stops. So the first time it comes through, if n is, first time it comes through, n is 2 now. So if 2 is less than 100, well, if 2 is greater than 100, then we break out. So 2 is less than 100, so we're not going to break out, we're going to print. And then we're going to start back up here at 3. And we're going to check if 3 is prime. If it is, we're going to yield second time through. That's a brief overview. Let's see what happens. Well, there's our 2, 3. Now 4 is not prime, so it didn't print 4. But it got all the way up into, so let's call next on, can we reuse our primes? Let's call next on primes. Oh, why can't we call next on primes? Function object is not an iterator. Oh, it's the function, right? So if we type primes, it's a function. So we have to call next on primes. So every primes was not defined right, actually, because it's always, first time it's called, it's always 1. So we can't reuse this particular implementation. We cannot reuse this. All right, so what is the type that returns from primes? A primes call. It does give us our generator. So we know that 4 statements can loop over list characters, dict keys, etc. Any sequence, any iterable. These are called iterable objects. The built-in iter function takes an iterable object and returns an iterator. So you can call iter on anything, and it makes it an iterator. Even though a list is iterable, it is not an iterator, so it doesn't have a next. So you can call next on an iterator of a list. So the assignment for this session is to write a conditional program with for and while loops using some of the iterable objects we've talked about. All right, so that was flow control constructs. And in the next session, we are going to talk about expressions. All right, so thank you very much.